anything that we talk about in this class can kind of fit into this two-dimensional diagram. And so I will often use it, and you'll see it in the pre-recorded lectures, that I'll like start off from here and then zoom into a particular topic and say like, this is what we're talking about today and how it's related to these other things. So I'm just going to spend a few minutes going over this diagram because it gives an overarching 10,000 foot view of kind of all of the issues related to global warming science and solutions. So basically everything starts with fossil fuels. So our three main fossil fuels are coal, oil, and natural gas. And we use coal to produce electricity in a lot of the world, not so much in California. We use oil to produce gasoline that we use in transportation. And then we use natural gas for power plants as well as for heating, both air heating and water heating. And so they really power the global economy. And one useful way of thinking about how large the global economy is and how much it is able to, or how much energy it consumes, is thinking about it through these four different factors. So you have global population, you have GDP per capita, how rich people are on average, or how much goods and services they consume on average. We have energy intensity of GDP, which means how much energy it takes to produce a given unit of goods and services. And then we have carbon intensity of energy, which is how much basically CO2, how much greenhouse gas pollution is emitted per unit of energy. So if any of these things go up, then we expect more greenhouse gases to be going into the atmosphere. And so that's the side effect, is that we're using coal, oil, and natural gas to produce about 80% of the energy that drives the global economy. And it has this side effect that it puts a gas called CO2, called carbon dioxide, into the atmosphere, which then interacts with plants and animals and the ocean and goes all over the place and affects all sorts of things. So the basis of our global economy, coming from burning fossil fuels, has the side effect that we put one very important greenhouse gas into the atmosphere. And there's other important greenhouse gases that come from basically from our food production system. So we have agriculture, and we use fertilizer, and that produces this gas called nitrous oxide that also goes into the atmosphere and is what we call a greenhouse gas. And then we have methane, CH4, which comes from producing rice for food and comes from the digestive systems of cattle. And so these are our three main gases that we worry about in this class: nitrous oxide, methane, and carbon dioxide. And we worry about those because they have this property where when we put them into the atmosphere, they allow sunlight to come in from the sun, but they disallow the Earth from having its energy escape to space. And so the more of those gases you put into the atmosphere, the more energy accumulates in the Earth system, and we get a increase in global average temperature. And so that increase in global average temperature then affects all sorts of weather events. And in particular, we worry about things that we call extreme weather events. So for example, wildfires in California are probably the biggest, most salient example of an impact from increasing temperatures. But other ones that get talked about a lot are tropical cyclones or hurricanes, changes in extreme precipitation, changes in floods, sea level increasing, droughts, heat waves. Potentially some locations might see an increase in cold even, but for the most part, we're actually seeing decreases in cold weather. So these extreme impacts, or these extreme weather events, then can be exacerbated by things called tipping points. So that just means that you kind of have a change that's slow for a while, and then all of a sudden it tips and you get this big change over a short period of time. So we'll talk about tipping points in one of our modules. And so then those have downstream impacts on things that we care directly about, like natural systems, so ecosystems. Some of the more sensitive ecosystems are in rainforests, or corals, for example, are very sensitive ecosystems. And then there's a bunch of kind of aspects of the economy, the human economy, that are affected by these changes in the climate as well. So high profile examples would be changes in agriculture. So as it gets warmer, and as you might see a higher frequency of droughts in some locations, that's bad for growing crops. Commercial fishing can be affected. As the ocean gets warmer, you can make ecosystems less healthy, and you have less fish, or you have fish moving away from places where you're fishing for them. Things like that. Human health is affected. So heat waves are a big exacerbator of poor health outcomes. Air pollution itself is a problem for human health, obviously. Things like property loss. So if a fire destroys paradise, then you have a bunch of property loss potentially affected by climate change. So things like that then inspire governments to make pledges to regulate various parts of their economies. And in particular, they try, or at least in their language, they discuss replacing our fossil fuel infrastructure with energy that, or with systems that produce energy but do not produce CO2 as a byproduct. So we tend to call those carbon-free energy or renewable energy. So the most famous ones are just wind turbines and solar panels. But then nuclear is another one that does not emit greenhouse gases as a byproduct. And then there's other things like electric vehicles, which don't emit CO2 or greenhouse gases out of their tailpipes because they don't have tailpipes. Now, if you plug them in to a system that is still burning fossil fuels, then there is still a carbon footprint associated with that. But if the underlying energy system is not burning fossil fuels and the car is electric, then you've eliminated the greenhouse gases from that situation. And so then the final thing is that governments might potentially in the future try to do something called geoengineering. So that would be something where we're not actually eliminating the emission of greenhouse gases, but we're trying to cool the planet through some other means, like putting dust up into the atmosphere and blocking the sun or something like that. So that's one of the riskier, more exotic types of strategies to deal with this problem.